Now let's find out what is the profession of an individuals that are greater than 30 years old. Let's see what the profession is. So a lot of people are artists. So what we're gonna do here is we are just going to see the profession. What's the most common profession? So the most common profession here, it looks like it's artist. Okay, so what we are going to see here is now what we are more interested in. We are interested in the profession and the annual income, right? Let's focus on that. Profession, and we are also interested in annual income. It's the profession. I think we spelled it right. Okay, so we missed this part. Let's see what the error is. So it's always the format is gonna be row and the column. The column that we would want to get is profession. And it's always the best idea to copy the column name from right here. So what happens if we do GF? So this is a row. So if we have a condition, we're gonna put it right here, right? So now let's say we would want to put the condition. The condition is going to be annual income got to be greater than $80,000. So this is the row and this is the column, right? It is way more clear than what it is. How it was before, 10,000, 100,000. Ooh. So what we gotta do is we are going to find provision that makes more than $100,000. Let's do the profession. No, count values, right? Our value counts. And this is pretty good. So even over here, the artist seems to be making a lot of price, a lot more salary than a regular individual. Subplot. Do we need subplot, layout, fixed size, use index, title, grid? Do we need all these values? I don't think so. Let's just let it be. So now what we are going to be doing is we are going to be using bar. This is real interesting. So now let's go ahead with the gender. All right. So we would want, do we want everyone? No, we don't want everyone. We would want the individuals with annual income. We're trying to see the gender, right? How many genders, how many are the male and how many are the female who are making more than $100,000. So let's go ahead and see. We don't really care about the profession, but let's go ahead and put this over here, annual income, and then gender. Okay, let's go ahead and copy this. And what we are going to be doing is I'm going to be counting value count. Okay, so there are more females, right? Would we be able to use more than? Okay. And this is interesting. So there are male and female artists, female and male in healthcare, female and male in entertainment, female engineers. So these are all males, right? Doctor, lawyer, executive. Female, male is a lawyer over here. Okay, cool. So what else do we want? Let's see the amount of family. Annual income is more than $100,000. Go ahead with profession. Annual income. We are trying to see the spending score. Let's go ahead and see the spending score. Okay, let's sort values with spending score. Ascending, false. We want the highest value on the top. So now what we will do is value count. Okay, let's just do the head. Yep. Let's go ahead and do 20. Okay, let's create a pie chart. Let's plot it. Kind is equals to, we would want to see the bar. Let's see how the bar is going to be. So where were we? Right here. So yeah, it's supposed to be 99, but $99 is not that far, right? So what if we do, instead of doing value chart, head, We do tail. This is pretty much the same. So let's just keep it at the head. Okay. So what we are going to be doing is we are going to count the spinning score. That mean 50. Let's go ahead. Oops. Let's go ahead and copy this guy, paste it over here. Let's see the median. This is still 50. Uh, let's go ahead and do value counts. So data in the table. So all rows. P the set option. Display option max. So what we're doing here is we're not setting any boundaries for displaying rows. We're supposed to set okay spending score rate. So before doing a value count, after doing value count, we sort values. Of course, ascending false to false. Which what does it mean? We would want to take this column and we are going to sort through the specific column. Let's go ahead and see if it works. It does not, because let the Gemini explain what the problem is. Okay, so it says it just takes one argument. That is totally fine. Okay, that is fine. So where were we? So displaying the head gives us a really different perspective. Let's go ahead and see. So what we are going to be doing is we are still interested in the individuals that are making a significant amount of income. Annual income that is higher than 150. Let's say let's go ahead and display all the columns. Let's go ahead and see if this works. It is working right now. Work experience and family size. Let's go ahead and see the shape. How many rows are there? 484. We're interested in work experience, sort values. $17. They're an individual with 17 years of work experience, even though their family size is 5. Okay, so what we are going to be doing here is, oops. So we are going to plot it. Kind equals to bar, and then x is equals to annual income and here y is equals to work. There we go. So what we are going to be doing is df. I would want to see the max. Okay, so with height ham, there's a lot. df annual income max. So this is the row rate. Let's see all the rows and the column. I'm not sure how this code is going to work, but what if we remove this guy, right? So what we can actually do is we're supposed to let's ask Gemini to answer our concerns. What we're trying to do is This is cool. Okay, this is just a really interesting way of. This is super simplified version of it, right? In chemicals, DF. So now we do have this number. What is the highest income rate? Provision annual income. As a dollar sign. Let's pull these guys out. Let's copy it right here. Let's paste it over here. Let's see what the explanation is going to be. Index of income. Display all columns for the highest annual income. Let's see how it goes. This is the index, right? We just grab the index. df.alloc 0 0 1 over by the row and 3. So it seems like spending around 45 minutes to an hour. There are a lot of data that can be interpolated. Full correlation between various columns. So this is the code that was generated by Gemini. Okay, so what we are about to do here is, this is where the map function signs. Map right here, we are creating a dictionary. Male is going to be 0. Female is going to be 1. Let's find the correlation. So the ideal case scenario is to give a numerical representation to these data points. So instead of doing that, what we are doing here is convert. I'm just going to be using numbers to correlate. We're just going to follow the instruction. This number. So what we are doing here is we are asking pandas to only select the data frame that has numbers or integers either in the columns or in each cell. So let's build correlation. It's always seaborn, right? Let's see. Annotation equals to true. So now let's go ahead to Gemini and ask explain this is happening in this correlation. One indicates perfect correlation, which is gender, and it's going to be gender over here too. Negative correlation. There are some correlation over here. Annual income and spending score. The more you make, the more you spend, right? Annual income versus work experience. The more work experience you do have, family size. Seems like there's a correlation between. Let's see what is it saying. By examining the correlation metrics, you can identify the relation of customer ID and annual income have correlation. So it does not matter, right? We don't care about the customer ID. So if we had to remove it, we should have removed it. Age and spending score have correlation, negative correlation. So it seems like there is no very high correlation between any of these columns or any of these data points. I will see you guys in another video.